This question is from the Geometry Regents, June 2016. It is question number 36. They are giving you a picture of a water glass and showing you that it could come from a cone. They also give you specific measurements of the cone. And then in the first part, ask if the base with a diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone, and they ask you to explain why. So I've broken the picture apart so that you can see the two cones with the measurements that are there. The diameter of the top of the water glass is 3 inches. The bottom of the water glass is 2 inches in diameter. The height of the water glass is 5 inches. And the height of the cone we're going to call h. In order to find what the height of the cone on the bottom is that would be remaining, you will need to use a proportion, and you can only do this if you have similar figures. That is why the two bases must be parallel to each other in order to find the height. Notice here I've taken a snapshot of the right triangle. If I use the radius of the top of the water glass, it would be 1.5 inches along here. And then the radius of the bottom of the water glass would be 1 inch. I want to find the height of the entire cone. I know the water glass is 5, which makes the bottom half h minus 5. Now you can see I have a right angle here, and if the bases are parallel, I have another right angle here, because parallel lines cut by a transversal, then the corresponding angles would be congruent. Since both triangles, the smaller one and the larger one, are right triangles sharing this angle, I have angle-angle similarity occurring here. That means I can set up a proportion because I have similar figures and solve for the height. One way to set up the proportion is to say 1.5 is to 1 as h is to h minus 5. It could have also been set up as 1.5 over h is equal to 1 over h minus 5. Cross multiplying in either proportion will lead you to 1h equals 1.5 times the quantity h minus 5. Once we distribute the 1.5 through, we'll have 1.5h minus 7.5. Now if we solve for h by subtracting the 1.5h from both sides, we'll end up with negative 0.5h equals negative 7.5. Divide both sides by negative 0.5 and we'll end up with the height of the entire cone being 15 inches. Using the height of 15 inches of the large cone, we know the smaller cone therefore has a height of 10 inches. And they would like us next to determine and state to the nearest tenth of a cubic inch the volume of the original water glass. Well, to do this, we'll need to find the volume of the large cone and the volume of the small cone. The difference of them will be this little water glass. The formula for finding the volume of a cone is equal to 1/3 times pi r squared times h. The pi r squared comes from that being the area of the base, which is a circle. So if we look here, we'll notice that the volume of the water glass, again, can be found by simply finding the volume of the large cone and subtracting the volume of the small cone. To find the volume of the large cone, again, recall the height is 15, and for that one the radius was only 1.5 inches. So the volume of the large cone can be found by substituting the radius 1.5 into the formula and the height of 15 into the formula. Remember, the formula was 1/3 times pi times r squared times h. This gives us 1/3 pi times 2.25 times 15, which is approximately 35.325 cubic inches. This leads us to having to find the volume of the small cone. Notice here, again, we're using the same formula, but this time we're using a height of 10 and a radius of 1. So the volume of the small cone, once we substitute the radius of 1 into the formula and the height of 10, we should end up with a volume of approximately 10.467 cubic inches. Since the volume of the water glass is the difference between the two cones, we will have to subtract these two volumes. When we do this, you'll notice we get about 24.858 cubic inches. The original problem asked us to round to the nearest tenth, so we'll take our answer we got here at the end and round that one to the nearest tenth. Try to go out a little further in your decimal places up until that point, so that at the very end is when you're doing your final rounding to the tenths place. Here we can see our water glass has a volume of approximately 24.93 cubic inches, which means it could hold up to 24.93 cubic inches of water.